is the maximum theta that I can allow right before the block starts moving. So now for the next problem, for the next part of the same problem, we will figure out what is the maximum value of theta right before the block starts sliding. The block starts sliding. So we understand that if I start increasing theta, I increase theta, theta is larger and larger and larger, and at some point this block will start moving. So force of gravity will be large enough to overcome friction. But what I'm looking for the maximum angle right before it happens. So where are we on this diagram? What is the magnitude of force of friction? The block is still at rest, it is ready to move right before it starts sliding. So we are right at this point now. Theta is not given anymore. We are looking for theta. So how will our equation will change? First of all, my magnitude of force of friction will be equal to mu static times n. So if coefficient of friction is given, in this case we neglected difference between kinetic and static, mu is provided, then I know the magnitude of force of friction and I have a change right here. So force of friction, I need to replace it by mu static n. Theta is maximum now, right before the block starts sliding. So this is F sub x is equal to max. Ax is still 0. The block is ready to move, but it is still at rest. And then balancing y, I have normal force minus mg cosine theta maximum is equal to 0. What we are looking for theta in this case. So let's solve this system of equations, because we know we have two equations in this case, and we have two unknowns. I don't know theta, I'm looking for theta, and I don't know normal force. So let's express normal force from the second equation. It is mg cosine theta maximum. And now I bring it into my first equation. I will have mg sine theta maximum minus mu static n, which is mg cosine theta maximum, and this is equal to 0. The block is still at rest. Can I solve for the angle? Yes. So first of all, I will divide both parts by m. I will also divide by both sides of equations by g. What I will do next I will divide both sides of my equation. Let me bring it. Sine theta max is equal to mu static cosine theta maximum, and I will divide both sides of the equation by cosine theta, which will bring me to tangent theta on the left. Tangent theta maximum will be equal to mu static. So we found the maximum angle that we can afford right before the block starts moving, and it is equal to the coefficient of friction.